Let's get started. So, this may or may not be a review for you. Either way, it is review. It's going to be a bit easier. If not, I'm going to explain it to you here. All right. So the first question, we're given two functions, f and g. So f of x, let's review something super simple here, which is, for example, f of x is the square root of x plus 3. So just, what's f of, I don't know, 4? What's f of 4? Yeah. So you just replace the x with a 4. So there's a 4 there and a 4 there. So this would be root 7. So do we understand the notation?
Yep. Mm-hmm.
So then you go, oh, you also got a g of x. So you plug functions into g. Okay. So if we say, what's f of g of 5? Well, what's the order here? Where does 5 go in first?
5 goes into
g first. So you'd go, okay, well, what's g of 5?
G of 5 is 24.
24. So instead of f of g of 5, since g of 5 is 24, you write f of 24. And what's f of 24?
Square root of 27.
Square root of 27, which if you wanted to simplify it is 3 root 3, because 27 is 9 times 3. Okay, how are our feelies about that? Pretty straightforward?
Mm-hmm.
Questions? Okay. What's this next thing? It goes G, this symbol,
So first reading which G
13. So, a little bit of notation here. What does this mean? This just is a fancy way of writing G of f of 13. Okay, that's all that is. Nothing scary. If you're wondering why invent that notation, what's the point? It allows you to do stuff like you can just talk about functions sort of in the abstract. Like I can talk about f, I can talk about g, and I can talk about f of g or g of f without having to have a bunch of parentheses and stuff. So that's kind of why. And if you wanted to have, for example, a huge composition of functions, like you wanted to have g of f of h of p of q, you could do that really easily, compose 5 functions and not have to use a whole bunch of symbols. So what's f of 13?
4.
4. So this goes g of 4. What's g of 4?
15.
15. Are there any questions? Okay. Sweet. Let's cover the rest so there's no confusion. Another kind of the same kind of notation. We could talk about f plus g of 6. That's just another way of writing f of 6 plus g of 6. What's f of 6?
3.
3. What's g of 6?
35.
35. So I guess f plus g of 6 is 30. Feel good?
Mm-hmm.
Okay. D, notice the symbol in the middle there is not the same open circle. It's a little dot, which means multiplication. So what's D going to be? We have f times g of x. So that's the same as writing, of 0, my bad. So that's f of 0 times g of 0. What's f of 0? Square root of 3. Oh, sorry, it's multiplication, not addition. And what's g of 0?
-1.
-1. So the answer to this one is negative root 3. Okay. All right, take a look at E. G of f of -4. Well, what's f of -4?
Doesn't exist. Can't do it.
That is undefined. Or we would say it doesn't exist. So if you can't plug -4 into f, then there's nothing to go into g. So you would just say this expression is undefined. Does that sound okay to you guys? And lastly, f over g of 2. That would be f of 2 divided by g of 2. What's f of 2? Root 5, and then g of 2 is 3, so the answer to that one is root 5 over 3. All right, does that all make sense? Okay, let's go over something a little bit more challenging. The other two on that page, hopefully, they should be pretty straightforward. I'm filming this for the millions of Twitch fans, so we'll just move on for the sake of brevity. All right, look at number 4. They give us 4 functions to deal with. And then we're going to be composing them in all sorts of weird ways. But you might notice that there's no numbers being plugged into the functions. It's just write a function for example. Okay, first question. What is the function f plus g of x and what's its domain? Your guys' favorite, right? Domain is definitely a crowd pleaser. What's Sarita? You said you love domain.
That's what D stands for.
Just to clarify, you said you love finding the domains of functions?
Yeah.
Okay. Good. That's what I like to hear. F plus g of x. Remember, that's the same as saying f of x plus g of x. Okay, so pretty straightforward then. What's f of x?
Root x plus 3.
The square root of x plus 3. And what's g of x?
1 over x.
Okay, now here comes the fun part. So in that case, that's pretty easy. I mean, you just add the functions up. But I'll sign
Its domain.
the domain, though. Let's look at what kind of numbers. What are some critical numbers to put on my number line here?
0.
0, certainly. What else? -3. Can x be -3? Is it okay to square root 0? Fine. That's fine. So -3 is fine. Any number bigger than -3 should be fine. 0 is not fine, but any number bigger than 0 should be fine. So that's my domain. So my domain is numbers, x values, that are greater than or equal to -3, except not 0. Kind of a weird domain, right? And if you really want to use interval notation, you could write this as, you'd go -3 to 0. Oh. Can't write today. Union 0. So from -3 to 0, and then from 0 to infinity, it's the other way you could write that domain. All right. How about k minus h of x? Well, what's k of x?
X squared minus 4.
4. And you're subtracting, be careful, you're subtracting all of h of x. And h of x is x minus 5. So you should probably put that in parentheses. When you subtract it, so my final function, I can actually combine some like terms here. X squared minus x. What else is left over?
-9 plus
Plus-
Negative, yeah, so -4 minus -5 is like saying +5, so it's actually +1. What's the domain of this?
Why is it in parentheses? Why is x minus 5 in parentheses instead of just combining?
Because we're doing k of x minus h of x. So this right here is h of x. You gotta be subtracting that entire thing away. If you didn't put the parentheses, then you wouldn't really be subtracting the quantity x minus 5. That make sense?
Yeah.
So what's the domain, guys?
Unreal?
All real numbers. Because you can square any number you want, right? You can subtract any number you want. So there's no division by 0 to worry about. There's no square rooting negatives to worry about. There's nothing like that. So, all right. Let's go over a couple more examples and then we'll just have some work time. Well, C, I think, is pretty straightforward. Let's go to D. Okay. K over G of X. Well, K is x squared minus 4, and G is 1 over x. So there's a big idea you gotta make sense of here, which is right now, looking at this, are there any numbers that x is not allowed to be? 0. You can't divide by 0, right? For example, and more specifically, I guess, 0 cannot go into G. So 0 is not on the domain. So the domain would be all real numbers except for 0. But then, this is the confusing part. You might go, wait a second, I can simplify this, can't I? What's dividing by 1 over x is the same as doing what? Multiplying by x. So I can really think of this as x squared minus 4 multiplied by x. So x cubed minus 4x. Do you understand that?
Mm-hmm.
But here's the thing. If I just told you that function, what would you think is the domain? All reals. But the domain's not all reals. So what you got to do is actually include that domain restriction as part of the function. So that is actually the function. Because and it's you. People always get confused by this because they go, wait, why do you have to put that in the function? How come you don't have to put that as part of this function? Because this is what we said the answer was, right? Why didn't I have to write comma this? Well, the domain is obvious from looking at it. If not obvious, it's clear from looking at it that if you look at this, you go, oh yeah, x can't be less than -3 and x can't be 0. But if you look at this, it's not clear at all that x can't be 0, so you can include that as part of the function. I know you guys are all dying to know, what would that graph look like? What kind of thingy would there be at 0? What kind of, not an asymptote, a hole. It would look like this graph. That graph looks like it's a cubic like that, but you put a hole at 0 because that's just a sort of a particular forbidden value. Okay? Okay, let's do F. I think F might be our last one to look at. No, I want to do
One of G through L.
I want to do H as well. So we're going to do F and then H. And that's it for, I think, all the examples I want to show you for now. Okay. So F is G over F of x. Okay. So g of x is 1 over x. And f of x is the square root of x plus 3. Let's write our domain right now. What's one restriction?
Can't be 0.
This can't be 0, that's true.
Negative
Can't be
It must be
negative.
negative.
Can't be less than -3.
Right, so, well, let's see, can I write this?
No, it cannot be negative.
It can't actually be -3, because then I'd be dividing by 0. On a number line, it would look like this. -3, have 0. So this one's really, really similar to the first one we did in terms of domain, but on this one, x cannot be -3. Now, can I write this a little bit different, a little bit nicer? No. Oh, we can. So here's an example. If I had 1/4 divided by 5, what's that the same as?
120.
1/20th, or 1 over 4 times 5, right? So this can be written as you okay with that? Now, do I need to write this as like part of the function?
No.
No, because it's already embedded. That information is embedded in the statement that x can't be 0 and x can't be -3 or less. All right, last one that we're going to cover as an example. H, right below that. H says, what's g of f of x? Okay. So we're, so what are we doing here? We're plugging f into g, right? So what happens if you go to g and plug f into it?
You get 1 over root x plus 3.
How do we feel about that?
Right.
We're sure we're okay with that?
Mm-hmm.
No,
No?
I've got no idea how we got it.
Okay.
Yeah, we're good.
Yeah, this tends to be pretty confusing, so let's look at g real quick. So g of x is 1 divided by x. So let's do a couple examples. What's g of 7? 1 divided by 7, right? What's g of apple?
1
1 divided by apple. What's g of hippo? 1 divided by hippo. So the idea that we're trying to show you here is g of a thing is just 1 divided by that thing. So when you look at this, you go, okay, well, what's g of f of x then? G of f of x would be 1 divided by f of x. Same idea. Okay, then what's f of x? F of x is the square root of x plus 3. And so, there you go. What's the domain? It's kind of similar to the last one. Let's do one more. Let's do one more composition like of. We'll do the one right below that. K of f of x. All right, K of f of x. K of f of x. So the first thing you might want to do, if it helps, is to go, this is the same as saying K of f of x. So let's use the same argument same kind of argument as last time. Well, what's K of banana? That's a banana, I think. K of banana is, I can't draw a banana.
Just write it
Very
out.
good.
Just do one line, just like a moon.
Just a single line, an
Yeah.
abstract banana.
Well, yeah.
I'll make a smiley face. How about that? K of smiley face is just smiley face squared minus 4. So therefore, K of f of x is f of x squared minus 4. Okay, so what's f of x?
X plus
Okay. Now, can I simplify this a little bit?
X plus 3
Because the square root of x plus 3 squared is just x plus 3. And then we go minus 4. So it turns out, I guess, that this is x minus 1. That's not quite right. It's not. That's not exactly correct.
Where?
Huh?
Where x cannot be less than 3.
Okay, or yeah, x is greater than or equal to negative. So this is how you write that function. That's because you had to look at the domain back here. So at this step, you had to be like, well, x can't even go into f if unless x is greater than or equal to negative 3. So that's got to be, when I do simplify this, I gotta do that. Does that make sense or no? By the way, what would that graph look like?
It would be a root.
I mean, what does that look like?
It's,
A
yeah, it's
line.
x minus
Straight
1
line.
it starts at.
So it would look something like this. Does that make sense?
Yeah.
So yeah, x minus 1, but it only for x values that are greater than or equal to negative 3. Okay, that's all my examples for you today. You can go ahead and do some problems.